Okay, so welcome to this video on writing and using linear functions. It's kind of like part two of that. We're calling it 6.3b. So if you want to put a part two here, that's fine, just so you know there's something that came before this that connects. And we're looking at this problem, and it says a manager earns $15 an hour and receives a $50 bonus. The graph shows the earning of manager B. So just keep in mind, if we color code here, manager B is this guy, right? And manager A is the other guy. Manager A is a different person. And he gets $15 an hour and a $30 bonus. So manager A gets the $15 an hour and a $50 bonus. So let's look, that's called the stem of the problem. Anything that comes before the questions, the information at the beginning, is called the stem of the problem. So I've color-coded the stem of the problem, and it asks which manager has a higher hourly wage. So we know that A, right, we know that manager A has a wage of $15 per hour. So $15 per hour is manager A. So we just really need to see what manager B's wage is. So manager B's wages are what? So how much is he making in an hour? So let's figure out what he goes up by when he goes over 1 hour. He goes up by what and over by what? It's not always going to be by ones. So the rise in this graph is not one. It's one square, but what's one square worth? $25, exactly. So he's making $25 per 1 hour because it's 1 hour of time. So manager B makes $25 an hour, and now we should easily be able to answer the question, which guy makes more money? We know it's going to be manager B, right? Yeah. So the answer to this one is B, manager B. He makes $10 more an hour. Sorry about my 15. It kind of looks like it's part of my dollar sign. So I'm just going to change that quick so it's obvious. He makes 15 an hour. So that wasn't bad. We're just comparing two different functions. They're both linear. We're trying to figure out who's got a better deal. After how many hours does manager B earn more money than manager A? Because manager B doesn't get a bonus, does he? Unfortunately. So let's think about different ways we could do this problem. So take a second. If you need to pause the video, that's fine. But think about how you might tackle this problem. Just the first couple steps. You don't even have to do the problem. Just think of what you might try, even if it's wrong. I'm going to check with my class and see if there are any thoughts. Do you have any thoughts on how we could get this? What do we think? Yeah, part B. How many hours till manager B earns more money than manager A? Yes.
Well, in 1 hour, it's still $10 more.
So in 1 hour, but remember that manager A has a $50 bonus. So if I was to just go ahead and start to graph this thing, I would say manager A starts right here. He gets a $50 bonus. Let's say it's Christmas time. He's already got $50. Or maybe he's like an on-call worker, right? Every time he gets called, he gets 50 bucks. So now let's figure out what's going to happen with manager A. How many hours will he go up to, like, let's say, I don't know, by $15 every hour, right? So after 1 hour, I'm going to go from 50, right? And I'm going to add $15 to that. He's going to have $65. So I'm going to go to where I think 65 would be, which is probably around here. It's an estimation. We don't really know. And then I'm going to say yes. Oh, 3 hours? Oh, easy. Okay, cool. So let's check it out. Let's make sure we'll confirm. So then I guess I'll speed it up because a couple of us are getting it now. So 2, I guess, would be at 80, so it'd be around here, right? And then after 3 hours, we'd be at 95, right? So after 3 hours, we'd be at 95, so it'd be right around here. I'm just approximating these points. They're not beautiful. Actually, it might take a little longer, yeah? Maybe 4 or 5. So then after, so 0 hours, so 1 hour, 2 hour, 3 hours, right? That's this table, 1, 2, 3. They're kind of backwards. 4 hours, he's going to have 110. So after 4 hours, he's at 110. He's about here-ish. After 5 hours, he's at 125. So after 5 hours, he's at... Oh, there we go. That's what we wanted. Isn't that what we wanted? So this line right here shows where they make the same amount of money. If they work how many hours, they make the same amount of money? How many hours? 5, right? If they work 5 hours, they make the same amount of money. Why is that? Well, if we look at the equations of these two guys, right? If we look at the equations just for a second, we got this one guy, manager A, right? And his job, and I'm just going to say A equals, his job is $15 for every hour, plus he gets $50 no matter what. Okay, that's manager A, right? And then manager B, right? Manager B, he gets just $25 an hour. So what we want to do is we want to figure out, when does A equal B? When do they equal each other, right? So all I do is I take A, which was 15H plus 50. That was his wages. And I take B, which was 25H, and I see when they equal each other. So that's what I kind of am doing here, right? I'm just adding up these two guys to get an answer. Or actually equaling them, not adding them, equaling them. So I set them equal to get an answer. So now when I do that, I can kind of figure out pretty quickly that 10H will equal 50 and H will equal 5. Hours is equal to 5, and we saw it right here in our graph. I'm just going to show you. 5 hours is when they made the same amount of money, right? So let's make this bigger and keep tackling this problem. So now we know that the answer to this is 5. I guess we're done actually at that point. It's only a two-parter. So 5 hours. So you see, actually, there were two ways we could have done this, the graph way and the equation way. I think the graph way in this situation is a little easier, but the equation way will always work as well. And the equation way is sometimes the way we have to go. We have no choice. So what I want you to do is I want you to think about this one for a second. This is actually just writing an equation from a table. It's a little different. It's kind of a review of what we did in the last video. So I want you to pause the video and try this problem. Even though it's not what we just did, it kind of is what we did in the last video. This is an approximation for the chirps per minute with the crickets. If you remember back, I don't know if I did it for this class, but we had a fact of the day, didn't we? About crickets chirping, didn't we? That's what this is actually showing. It's kind of funny. I didn't plan this, but I didn't even know this was a question. But as the temperature goes up, the crickets chirp more. That's how it works. And as the temperature is down, they don't really chirp. And they don't chirp until it's over 40 degrees. So pause this video and give this problem a shot. If you're not quite sure how to start, I'm going to give you a little bit of a hint. So we kind of want this equation, right? We want this y equals something x plus something. We want to fill in these two things, mx plus b. The way we're going to figure this out is we're going to figure out change in y, which it does seem like it's going up by the same amount every time, right? Plus 4 each time. So change in y is 4 over change in x, which I think is plus 16 every time. So that is that problem. 4 over 16 is 1/4, right? So we're getting pretty close, and we need to know what is the starting point. What is the y-intercept? So we have y equals 1/4 x plus. Yes, do you want to jump in? Let's see. I think that 0, when x is 0, what is y? Yeah? What do you think, Angelina? 40, yeah, good. So, sorry, I was trying to pause the video and have you try it, but I think if I reduce that, I'm going to have 40 as the y-intercept. So when the x is 0, the y is 40, so that's where that's coming from. So that's what's going on. If there are no chirps, what is the temperature? Yes?
40 or lower.
Cool, 40 or lower, exactly, good point. And if there are, let's say, there are, I don't know, let's say there are like, maybe there are 128 chirps. So what if there were 128 chirps? How would we figure that out? So what I would do is I would take y equals 1/4. This is the number of chirps. plus 40. And I said, what if there were 128 chirps? Well, I'd take a quarter of that and add 40, just like the fact of the day said. So what's a quarter of that? I think it's 32. So we have 72 degrees. Make sure I didn't make any mistakes. So it's 72 degrees out if there are 128 chirps per minute. So they're chirping twice every second, right? So you count 5 Mississippis and you have 10 chirps. It's about 72 degrees outside. Give it a shot this summer, okay? When it's a nice evening and it's kind of maybe in the 70s, count the cricket chirps. I know I will for sure, because I've never really experienced this. I just looked it up as a fact this year, and then it came up as a problem. Kind of cool. All right, so are we okay there? Yes? Okay. So it seems like we're doing pretty solid here. So let's go on and talk about the last part here. We're talking about whether something's linear or nonlinear. That's what we're really doing here. So I want to show you one or two, and then just maybe you can get it from there. So if I was to look at linear and nonlinear, I just want to see if the change in y and the change in x is consistent. If the change in y and the change in x is consistent, I know it's going to be linear. So here I have minus 2, here I have minus 2, here I have minus 2. That's my change in y. Here I have plus 1, plus 1, plus 1. Do you think it's linear or nonlinear? These are just true or false questions. True or false, or linear and nonlinear, right? So we're just going to put an L or an N. So what are our thoughts on the first one? Anybody? Go ahead, you can say it. What do you think, people? Linear is correct. Good job. So linear because of that form, okay? So there's the first one. Then we'll do this guy right here. And then we'll do this guy right here, okay? So we'll just slide that up a tiny bit and we'll be good to go. So I would say the first one is linear. Let's look at the second one. Does somebody want to jump in and tell me what they think the second one is? And those at home should just kind of think about it. We're going up by 2, up by 3, up by 4 here. So I would say we went up 2, up 3, up 4 here. We went up 1, we went up 1, we went up 1. Linear or nonlinear? Nonlinear. So let's do this. I'm just going to write linear in green like it's a go. It's linear. And then I'll write nonlinear in red like it's a no. Nonlinear. If it doesn't change consistently, it goes up by the same amount every time. No matter where you do rise over run, no matter where you do the slope, it's nonlinear. Because on a line, the slope is always the same, correct? Anywhere on that thing. But if you're like actually in real life, like going up a hill or a mountain or skiing, usually the slope changes a lot, right? And so it's not a line, it's not linear. But a handicapped ramp is linear or nonlinear? A handicap ramp is linear, but a water slide is probably not linear, right? Agree? So it doesn't change by the same part. The water slide might start out really shallow and then get really steep and then something like that. You know what I'm saying? It probably has a curve to it. It's not linear. So that's what's going on. Let's look at the next one. What is the change by? It looks like it goes up 10, down 5, up 10. Right? And then it goes up 1, up 1, up 1. Linear or nonlinear? Yes? Nonlinear. Pause the video and try the last one on your own. So pause the video and give this a try. We know this is nonlinear because it doesn't go up by the same amount. It's all over the map. And try to think of what the last one is. I'll see you in a second. So hopefully you felt fine about that one. And you looked at the change in y over change in x. So the last one here is really just, does it represent a linear or nonlinear? And they kind of did out some of the work for you. So is this linear or nonlinear? This one's linear. So I'm going to put a big L here for linear. Okay. And then how about this last one? Is it linear or nonlinear? nonlinear. Pretty straightforward, right? And if I was to give you a graph of linear and nonlinear, you think you could handle that? I mean, it's not that bad. Here's the question. Can you tell me if this is a linear or nonlinear function? Linear or nonlinear? Linear. How about this one? Linear or nonlinear? Nonlinear. Very good. Do you think this is going to be a hard question? Not really, right? Okay, check it out. Linear or nonlinear? I'm not going to try to trick you. Does it look linear or nonlinear? It's a line. It's linear. It's a line. It's not supposed to have a curve to it. So that's where we're going to end the video. If it's a line, it's linear. If it's not a line, it's nonlinear. I don't know how much easier that can get. So we'll take a break here. We're going to end, and I'll see you in the next video. Peace.